Hello, I am Geeta Babu Singh, welcoming you all again to this session. In previous session, we discussed data communication, components of data communication, that is message, sender, receiver, transmission medium and protocol. Then we studied data representation, in which we studied text, image, audio and video. In today's discussion, we discuss on line configuration, point-to-point, multi-point, topology, mesh, star, tree, bus, ring and hybrid topology. Let us start with networks. A network is a set of devices referred to as nodes connected by communication link. A node can be a computer, printer or any other device capable of sending and or receiving data generated by other nodes on the network. As shown in this slide, so here we have connected internet to firewall, then to wireless router. From wireless router, we connected that to iPhone, printer, laptop and desktop computer. So let's repeat the definition of network. A network is a set of devices, often referred to as node, connected by communication link. A node can be a computer, printer or any other device capable of sending and or receiving data generated by other nodes on a network. So in this figure also, the computer and printer are also capable of sending and receiving the information, that is data. Now, a network criteria. A network must be able to meet a certain number of criteria. The most important of these are performance, reliability and security. Let us see one by one. Performance. Performance can be measured in many ways, including transit time and response time. Transit time is the amount of time required for message to travel from one device to another. Response time is the elapsed time between an image inquiry and response. The performance of network depends on a number of factors, including number of users, the type of transmission medium, is capabilities of connected hardware and efficiency of software. Performance is often evaluated by two networking metrics, throughput and delay. Next one is reliability. In addition to accuracy of delivery, network reliability is measured by frequency of failure, the time to take a link to recover from a failure, and network robustness in capsaphone. Next is the last one is security. Network security issue include protecting data from unauthorized process, protecting data from damage and development, and implementing policies and procedure for recovery from breaches and data losses. Now let's see types of connection. The first one is the point-to-point and multi-point. A network is two or more devices connected through links. A link is a communication pathway that transfers data from one device to another. For visualization purpose, it is simplest to image any link as a line drawn between 2 points. For communication to occur, two devices must be connected in some way to the same link at the same time. There are two possible types of connection, as I told you earlier. First one is a point-to-point and multi-point. Let's see the point-to-point. A point-to-point connection provides a dedicated link between two devices. The entire capacity of link is reserved for transmission between those two devices. Most point-to-point connection use actual length of wire or cable connected the two ends, but other options such as a microwave or satellite link are also possible. When you change a television channel by infrared remote control, you are establishing a point-to-point connection between the remote control and television control system. So as shown in this slide, in the picture, we have two boxes, that is a station 1 and station 2, and one line that is a link. So as the name, a point-to-point connection provides a dedicated link between two devices. So this is nothing but a point-to-point connection. Now let's see the second one, that is multi-point. A multi-point is also called multi-drop connection, is one in which more than two specific devices share a single link. In a multi-point environment, the capacity of channel is shared either spatial or temporarily. If service devices can use the link simultaneously, it is spatial shared connection. If users must take turns, it is time shared connections. So as we can see in the slide, we connected a main frame to a different station, that is, as we told in definition, a multi-point is connection in which two or more specific devices share a single link. So from main frame, we have one line, that is single link, from which we are connected three stations. So three stations. Next, see the criteria of topology. So the term physical topology refers to the way in which a network is laid out physically. One or more devices connected to a link, two or more links from a topology. The topology of a network is the geometric representation of the relationship of all links and linking device, usually called nodes, to one another. There are four basic topologies. Possibly mesh, star, bus and ring topology, as shown in this slide. So here we have a topology to which we are connected bus, mesh, star, bus and ring topology. So let's see one by one. What is mesh topology? In mesh topology, every device has a dedicated point-to-point link to every other device. The term dedicated means that the link carries traffic only between two devices it connects. To find number of physical links In a fully connected mesh network with n nodes, we first consider that each node must connect it to every other node. Node 1 must connect it to n minus 1 nodes, and node 2 must connect it to n minus 1 node, and finally n must be connected to n minus 1 nodes. We need n bracket n minus 1 bracket close physical link. However, if each physical link allow communication in both a direction, that is duplex mode, we can divide the number of links by 2. In other words, we can say that in mesh topology, we need n bracket n minus 1 bracket close divided by 2 duplex mode link. To accommodate that many links, every device on the network must have n minus 1 input and input output ports to be connected to other n minus 1 station. The advantage of mesh topology. The advantages of mesh topology. The use of dedicated links guarantees that each connection can carry its own data load, thus eliminating the traffic problem that can occur when links must be shared by multiple devices. Second is, a mesh topology is robust. If one link becomes unusable, it does not incapacitate the entire system. Third, there is an advantage of security. When every message travels along a dedicated line, only the intended recipient see it. Next, there are two disadvantages of mesh topology. The first one is disadvantage of mesh are related to the amount of cabling, because every device must be connected to every other device. Installation and reconnection are difficult. Second, the sheer bulk of wiring can be greater than the available space in walk, ceiling or floors can be accommodated. Finally, hardware required to connect each link, that is input output ports and cables, can be prohibitively expensive. For this reason, mesh topology is usually implemented in limited fashion. For example, as backbone connecting the main computer of hybrid network, that can be include several topology. Next is star topology. A star topology connected 4 stations. In a star topology, next is a star topology connected 4 stations. Each device has dedicated point-to-point link only to a central controller, usually called hub. The devices are not directly linked to one another. A star topology does not allow direct traffic between devices. The controller acts as an exchange. If one device wants to send data to another, it sends the data to the controller, which then relays the data to the other connected device. So as shown in this slide, here we have a connected hub through which we are connected 4 different stations. So as the definition of star topology tells that each device has a dedicated point-to-point link only to the central controller, usually called the hub. So, as the definition told, so here we also connected hub. The stations are connected to hub. The advantage of star topology are a star topology is less expensive than mesh topology. In star, each device needs only link and one input output port to connect it to any number of others. If one link fails, one that link is affected. All other links remain active. One big disadvantage of star topology is the dependency of whole topology on one single point, the hub. If the hub goes down, whole system is dead. And next is a bus topology, connected 3 stations. So, a bus topology is multi-point. One long cable acts as a backbone to link all the device in a network. So, as shown in this slide, here we have connected one cable to 3 different stations, and that cable is nothing but the backbone of the device. So, nodes are connected to bus cable by drop lines and tapes. So, as shown in figure, the nodes are connected to bus cable by drop lines and tapes. A drop line is a connecting connection running between the device and the main cable. A tap is a connector that either splice into the main cable or puncture the shitting of cable to create a contact with metallic core. So, in this as shown in this figure also, we have a cable to which we are connected 3 stations by drop line and tapes. The advantage of bus topology are each of installation backbone cable can be laid along the most efficient path, then connected to the nodes by drop lines of various length. In this way, a bus uses less cable than mesh or star topology. So, disadvantage of bus topology are it is a difficult reconnection and fault isolation. A fault or break in the bus cable stop all transmission even between devices on the same side of the problem. The damaged area reflect signal back in the direction of origin, creating noise in both directions. Next one is the ring topology connecting 6 stations. In ring topology, each device has dedicated point-to-point connection with only the 2 devices on either side of it. A signal is passed along the ring in one direction from device to device until it reaches its destination. Each device in the ring incorporates a repeater. When a device receives a signal intended for another device, its repeater regenerates the bits and passes them along. So, as its a definition, a ring topology In this slide, the picture shows a connection ring which is connected to one or two stations forming a ring. A ring is relatively easy to install and reconfigure. Each device is linked to only its immediate neighbor, physically or logically. To add or delete a device requires changing only two connections. In a simple ring, a break in the ring, such as disabled station, can disable the entire network. So next is hybrid topology. A network can be a hybrid. For example, we can have a main star topology with each branch connecting several stations in a bus topology. So, as we know, in a bus topology, one long cable acts as the backbone to link all the devices. And in hybrid, a network can be hybrid. We can, for example, we can have a main star topology with each branch connecting several stations in bus topology. So, here by using a single cable, we are connecting one or two stations. So, as shown in this slide, so we are by using a single cable, we are connecting one or two stations, and one that is bus one that is defined the definition of bus. So next is in star topology, we are using a hub to connect all the stations. So similarly, combining those two, so we are forming hybrid topology. A hybrid topology, a star backbone with three bus networks. So here we have three bus networks, that is three cable which are connecting to one or two stations, and one hub which is nothing but as in our star topology. So let us see some questions. Frequency of failure and network recovery time after failure are measure of the dash of a network. So the answer is reliability. Which topology requires a central controller or a hub? Star topology. Which topology requires multi-point connection? That is bus topology. Dash connection provides a dedicated link between two devices. The answer is point-to-point connection provides. Thank you.